Alrighty, welcome back. So we just finished with our preliminary grouping of our components. So the next step is to start actually placing components on the board. So quickly what we'll do is we'll do a right click merge all, so that now we have one window, so now we can just work in this single window to make things nice and neat for us. And then I have some notes I want to go over for what we're going to be doing next. So we're actually going to be placing these on the board, and I'll show you how I go about doing that. So just some quick notes I have for this section, so some general guidelines. We want the components to be as close as possible to mitigate parasitic inductance and minimize trace resistance. So what I mean by this is, if you can afford to put it closer without too much hassle, then go ahead and do it. But this is something to consider, though, is you not only do you have the component, but you have like the silk screen to worry about as well. So you'll have, just to quickly look at this, so like you're never going to, when it comes to placing components, you're never going to be able to place these pads like right on top of each other, you know. You're always going to have the silk screen, and you're always going to have like mechanical component bodies. Those are going to be your two biggest mitigating factors. So getting one pad as close as possible to another is not really your worry here. So that's kind of what I say about that. So when I say as close as possible, I mean like you're not going to be achieving anything where they're like literally on top of each other like this, because like you see, we have these massive component designators, and these are absolutely essential for validation and circuit testing purposes. So it's not like we can just get rid of them or shrink them down, because you also need to be able to see them with your naked eye, or else they're just not very useful. So that's just a fact of layout design and PCB layout, that's something you have to deal with. So it's not really a problem at all. So it won't be an issue for us. Another consideration is thermal performance. This is a good point, and we'll cover this more in detail, but the idea is just know which of your components will heat up, right? So this, when I'm talking about thermal performance, we know like rectifier diodes get hot, your MOSFET's going to get hot, your common mode choke will get hot, and your filtering inductor will get hot, right? So that's just a brief list of things to be aware of, especially when we're talking about the high voltage side. Is so don't place those hot components right on top of each other, because just the concentration of high amounts of thermal energy will just cause a lot of problems for actual like real life user experience. Like they pick up the power supply and it's kind of hot in their hand, and they don't like that. And then also actual board performance. So you could be warping the board, you could be reducing the longevity of components by doing this. So just be very aware of what components get hot, so you can appropriately space them, maybe place them on different sides of the board so the board can act as like a heat sink, stuff like that. So I'll show you exactly how I do it whenever we do the actual layout. And then what else do I say? Yeah, so don't place these components right next to each other. Component bodies will usually be the greatest obstacle. So it's kind of something I mentioned before. So like bulk capacitors. So we'll quickly look at the bulk capacitors. So where are they? So these things, right? So the pins are, so these two bulk capacitors we know will be like connected to this rectifier diode. Like putting these like right on top of each other, or these two bulk capacitors will be connected to each other, right? Putting them right on top of each other is just not possible, right? They're going to be spaced out like at best they'll be like this far away from each other, right? Which is still a pretty great distance. So don't worry about that. Like that's just a matter of fact for PCB layout. So don't worry about that too much. So yeah, but that's what I was talking about in terms of mechanical bodies of components. And that's also generally how it goes when you're trying to place things together, is you just kind of inch things as close as they can from a, think of it in terms of a mechanical perspective, is what I'm trying to say. So mechanical will be raised optical. So yeah, so we got SMD components. That's what I was talking about, choke. So these components are actually pretty large in terms of the mechanical bodies, versus what I'm comparing is their actual footprints versus their real life sizes. So looking at the footprint, like you think this thing, okay, it only has 4 little pads, but really in real life it's much larger. So I don't know if, so like here, look, it's actually like looks like this and that, right? even though all you see from a layout perspective are these little pads that you got to try to touch together. So I'm saying focus more on these blue boxes right here when it comes to placing your components and placing something that that makes sense from a mechanical perspective, from a blue box perspective. Hopefully that helped, and we'll show examples of how I do it. So we used 0402, 0603 packages for SMD components that went near the controller IC, so we placed as close as possible. This was something that was mentioned in the data sheet and some of the layout guidelines that we wanted, because it just said, oh, these capacitors need to be as close to the pins as possible for best performance, etc. So that's kind of what we did. Optocouplers kept away from transformer because of EMI considerations. So we'll get to this later. So this will probably be a multi-part like video where I place all the components. I think it's now time we can just jump right into it. So we'll just start with, I think a fine place to start with is generally what you want to do is start with your connectors, right? And we actually only have like sort of 2 connectors. We have actually 1, and then we have 2 mounting holes, but we can still appropriately space those things out. So it looks like P1 is our first connector. So, and what I'll do is we'll toggle back and forth between 3D layout view just to make sure that I mean, this 3D model isn't the best. It's mostly for just visual, so it's not really like, because usually we'd see like the inputs and stuff, but it's still good for just visualizing it mechanically and how things will look. So I think it's fine. We'll just put it near the middle. These are our actual connections right here. And we'll just kind of inch it up here towards the edge of the board. And I think this is a fine place to begin. So then the next thing we want to do is let's look at our circuit real quick. So we know it goes connector, then we got our X cap, then we have our common mode choke, and then we have our rectifier diodes. So X cap, common mode choke. Oh yeah, another thing that I did is here we go view, and then we go connections, and then we can do show all. Let's see, we'll update this. So if we do view connections show all, and I do not know why that doesn't pop up, but here we go. So one thing, you see one thing we want to do when we're preliminarily placing components, I don't like this rat's nest, so we'll hit view connections and we'll do hide all, and I actually have that shortcut as shift control, or what I do, shift control C, and so that just hides all of them for us, so it's not annoying to place components. So but yeah, so next is the X cap, which is C4. So we'll kind of place that right around there, I think is fine. And then we have our common mode choke. Place that right around there. And yeah, you can hug these things as close as they can get. This is fine. And again, we're just doing some preliminary placing, right? So yeah, I'm just going to go through. So this is pretty much how I want to start out the circuit with these main components. I'm just stacking them back to back to back. And then let's see what else. And then we'll stop at our rectifier. So that is this thing. And so let's see. So the rectifier I'm going to put on the bottom side. So these are all, one thing to note, if you click a view 3D layout, these are all through hole components, right? So they all have pins going through the circuit. Okay, so I think I actually found a mistake here and I'll fix that, but these are all through hole, and then we have this SMD component. So what I want to do actually is put this one on the bottom side. Something like this. Yeah, you can actually get this pretty close too, as well. Since this is on the other side, right? These won't overlap at all if I literally put them like right there. But there's a large amount of pins going through them, so we don't have to worry about. So we can't do that. So yeah, I think that's where I'm going to wrap up this video. Just some of the preliminary component placement, and so what we'll do is we'll step through each subsection of the board, and then we'll I'll show you how I placed every single component. So yeah, if this video helped you out, please drop a like for me. That would really help out my channel, and subscribe if you want to stay up to date with all the videos that I'm going to be posting in this project series. I also post a lot of other electrical engineering related content, so you might be interested in that. Thank you so much if you made it to the end of this video, and hopefully I will see you in the next one.